Well, it's 15 minutes until we are live for our live lesson.
We're really looking forward to it and we're ready to go.
So we'll see you there. welcome to DE's live lesson, TikTok, Insects Don't Stop. The theme for Science Week this year is time, and we are exploring the amazing links between insects and time. I'm Katie, and I will be guiding you through this live lesson today, and I'm joined by Mike Linley, who is a zoologist and expert on all things animals. Thank you to all the schools that are joining us across the country. Teachers, you can type your answers to the challenge question and any questions that you or your class might have for Mike during the session, and we will try to answer these at the end. It would be lovely to see which schools are joining us. Please write your class name in the message box and we'll be able to say hello. So far, Ash class from Clifton All Saints Academy are really excited to be learning about insects. That's brilliant. There will be activities for you to complete throughout the lesson, and please fill these in on the handout provided by your teacher. I hope all at Year 2 at Primrose Hill are ready for the live lesson. Today we're talking about insects and time. Mike and I have visited the Bug Park in Norwich to find out about some interesting insects. So we're first of all looking at this colony of leafcutter ants. Mike, can you tell us a bit about them?
Yeah, well, it's very hot in here for a start because these ants come from Trinidad and South America, so it's very hot, humid forests. And they're called leafcutter ants because they cut leaves, which they take back to the nests. Now, they don't actually eat the leaf. They just take it down deep into the nest, which is where the queen is. The fungus on those leaves, and that fungus is unique to leafcutter ants' nests, not found anywhere else in the world. So they grow a fungus, and that's what they and their larvae feed on in the nest. The female queen is huge, and all she does is pump out eggs day after day after day, and she can live for 30 years.
Wow.
And she is producing the entire colony time and time again, year after year. What you'll notice is that there are medium-sized ants actually cutting the leaf, and they cut a leaf by working around it, and it's usually a leg span big, and they know that size they can carry. Then they hoist it above their head in their jaws, and they carry it like a sail all the way back down into the colony. And there are soldier ants that guard the route, and you'll spot a soldier ant because they've got great big heads, because they've got great big jaws. So they need a big head to support the big jaws, and they protect all the ants that are travelling around the forest, bringing leaves back to the colony.
And that is the first challenge question that we have for you all. How long do you think it will take for this colony of ants to strip these leaves here? Put your guess as a class into the comments and we'll reveal the answer at the end. It's time for activity number 1. On your handout, tick the animals that you think are insects. This is activity 1 on your handout. If you know any more insects, please write the name of the species down as well. You have 2 minutes to do this. insect an insect?
Right, well, insects have three body parts. Front end, they have the head, which has got the eyes, the antenna, and the mouth. Behind that is the thorax, and from the thorax there are 3 pairs of legs and 2 pairs of wings normally. And then at the end, the last segment, is the abdomen, and that's where all the sort of stomach is and the sort of fat content and all the reproductive organs. They're in the end bit. So head, thorax, abdomen.
Remember, if you have any questions for Mike about insects, please do write these in the comment box and we'll try to answer them. And keep putting your guesses into the challenge question. Hello to the Ladybird class at Attleborough Primary School and bonjour to the British School of Paris. Let's have a look at the answers to Activity 1. I wonder how the pupils at Ivy Bank got on. These 4 animals are insects. The koala is a mammal, so that's not an insect. The crab, spider, and millipedes are also not insects. So we're now going to look at one of the insects up close and really discover the features of what makes an insect. Mike, what have you brought along?
Well, the first insect, this is a locust. In this case, it's a desert locust. Now I'm going to hold it by the wings because they do fly, they fly very well. So by holding the wings together, it's not going to suddenly disappear around the room. Now at this end, we've got the head. So there's the head with the antennae and its eyes. Then behind the head is the thorax, and it's the thorax where all 6 legs come from, and also 2 pairs of wings. They all come from the thorax. And then behind the thorax, you can see here, there's the thorax, and this is the abdomen. This is a squishy bit down at the bottom where all its body parts are. So this has taken about 3 months to get to this size, and it will probably live for another month.
Brilliant. And you'll see that I'm not handling the insects, and that is because Mike is really experienced with handling these animals and knows how to handle them safely. So I'm going to watch from a distance. So it's now time for activity number 2. With the information that Mike has just showed us, can you label the parts of the locust using the word bank on your handout? You have 3 minutes to do this.
So insects have three body parts. They have the head, which is where the mouth is, the eyes, and the two antennae. Behind the head there is the thorax, which is where the three pairs of legs come from and the two pairs of wings. And then behind the thorax is the abdomen, three main body parts.
So there are the answers to that activity. We're now going to look at the life cycle of an insect and the stages it goes between the egg and the adult. Mike, what have you got here?
Well, I thought I'd bring something a little bit different. Here we've got some stages of the flower beetle, all right? Now, adult flower beetles will lay their eggs in the ground, and those tiny eggs will hatch into tiny little grubs. Those grubs will start to feed in the soil on vegetable matter, roots, all sorts of things, and they start to grow. So this is one, several months old now, and you'll see it's quite a fat little grub, lots of food stored in there, a pair of jaws at this end, and the three pairs of legs already towards the head end. As it grows, it gets bigger, and at some point it will then metamorphose into the next stage, which is the pupa or chrysalis. And this is its pupa of the same beetle. Now you can see it doesn't move, and it's in this sort of phase for maybe a month or two. And during this time it's quite vulnerable because it's just sitting in the soil, it can't defend itself, it can't move. So what it does is it makes itself a little cocoon like this out of the soil, all glued together, so it sits inside this cocoon. I've taken it out of its cocoon just to show you, but it would be protected by this hard shell while it's in the soil. And once all the sort of body parts have changed from the body parts of a grub into the pupa, it's going to hatch out into beetle. So all the sort of cells are reorganizing themselves now inside the pupa, and it will eventually emerge as an adult, fully grown from the soil. Now I've got an adult beetle here to show you. This is an adult flower beetle. They can fly, so I've got to be quite careful. And this is the adult here. So this is the flower beetle, and again you can see the head, the thorax and the abdomen. These are the wing cases, the hard bit.
So we have the stages of the life cycle is the egg.
The egg.
Which changes into, and in this beetle it's called a grub.
We call beetle larvae grubs.
Okay.
A butterfly larva is a caterpillar.
Okay, so we've got the egg, the larva.
Yep.
And then?
The pupa or chrysalis.
Yep.
And then the adult beetle itself.
It's now time for Activity 3. Can you order the stages of a beetle's life cycle? Put the number in the box and label each stage using the word bank. You have 2 minutes to do this. Here are the answers to Activity 3. The first stage is the egg. The second stage is the larva. The third stage is the pupa. And finally, the fourth stage is the adult.
Do keep your guesses coming in for the challenge question that we set at the beginning of this session. The flamingo class at Hill House Primary School reckon it will take a day for those ants to strip the leaves. We'll find out later on in the lesson what the right answer is. There's such an amazing variety of animals on display at the Bug Park.
It's an enormous place. They've got mainly arthropods, so that includes the insects, crabs, millipedes, centipedes, spiders and scorpions, but also got giant land snails and leeches. So it's an incredible place to go around and have a look.
Well, let's learn more about one of these arthropods. Look at the differences between insects and millipedes, and here we have a giant millipede. Mike, can you tell us a bit about this giant millipede?
I can. It's big. It's one of the biggest millipedes going, the giant millipede, and it doesn't have the same body parts of an insect. An insect has the head, the thorax, the abdomen, 3 pairs of legs, 2 pairs of wings usually. The millipede has more legs, no wings. What it has is a head and then a very long segmented body all the way down to the tip. And each of those segments has 2 pairs of legs, so 4 legs per segment. Now, a millipede, you'd think, oh, it's got 1,000 legs. It hasn't got 1,000 legs. It's got between 200 and 300 legs, depending on the species. So 2 pairs of legs per segment. Now, throughout its life, the millipede doesn't undergo metamorphosis like insects do. It doesn't change drastically from one stage to the next. Millipede lays eggs. They hatch into little tiny millipedes and they grow. And after a few months, they get to this sort of size. And you can see it's identical to its parent, different colour, but it's exactly the same format, the same shape, the head, the segments, the number of legs. And then a few months later, it's grown again to this sort of size. So they don't change, all they do is shed their skin between each growing spurt, and they eat the skin to recycle it. Now, creatures such as this millipede are really good at recycling. They can take any sort of plant waste, eat it, and then they actually make from it great compost.
So the diet of a millipede, that eats sort of soil and
It eats dead leaves, decaying matter, decaying fruit, and then it produces perfect compost.
So comparing that to an insect, what would an insect normally eat?
Most of them eat leaves, the herbivorous ones, and the others are carnivorous ones, and they eat the herbivorous ones. So insects can be carnivorous or herbivorous, and some omnivorous, so eat both plants and animals. But millipedes are purely detritus feeders.
So Mike has told us about some of the features of a millipede. It's time for activity number 4. Discuss the similarities and differences between a millipede and an insect. I wonder how many facts the pupils at 2S at Brackenwood Infant School could remember when doing that activity. At the start of the session, we asked you a challenge question. How long would it take for those ants to strip the leaves? Shall we find out the answer? Don't those ants work fast? Thank you to everyone for your guesses to that challenge question, and well done to Class 6 at the Co-op Academy in Oakwood. You were very close. So it's now time for us to answer some of your questions. Year 2 at Low Ash School have asked, are bugs still being discovered, and what was the most recently discovered bug?
Oh wow, yes they are. There's lots and lots, mainly small insects, usually beetles and tiny wasps. In an average year, probably 80 or 90 species of beetle are discovered. In the past 4 weeks, 3 species of beetles have been discovered. Less so things like butterflies and moths, because they're quite obvious when you see them, so there are fewer of those. But little tiny beetles, little tiny moths, every year, several hundred.
Wow. And we've had another question from Lowick and Holy Island School. How long does the longest living insect live?
Well, we think it's a queen termite, because the colony lives as long as the queen. Of course, when she dies, the colony dies. And we know that colonies have lived for up to 50 years for certain. Some people say 75 years. So that's the longest that we know.
And another question from Our Ladies Primary School, Amelia has asked, how many insects are there in the world?
Blimey, I don't think anyone has ever counted them, but one estimate I saw was 12 quintillion. I don't know what a quintillion is, but I do know that works out to be 1.4 million per person on the planet.
Wow. Another question from 1B at Spring Hill Primary School. Are insects always tiny?
Usually, yeah, it's the way they're made, the way they breathe. They don't have lungs like us, they have spiracles on the side, and that limits how big you can be with that type of respiration. So normally very small. The biggest fossil we have is of a dragonfly which had a wingspan of about 60 centimetres. But that lived millions of years ago when the atmosphere was probably different and it could breathe.
And so then another question from Gorgam Blackrod Primary School. What is the biggest insect in the world?
Depends what you mean by biggest. In terms of length, the biggest insect is the Chinese giant stick insect that gets to 60 centimetres long. The heaviest is probably the Hercules beetle that gets to about 75 grams in weight. Its larva, its grub, that can be heavier. So the grub of the Hercules beetle can weigh up to 100 grams.
Wow.
But it shrinks a bit when it changes to a beetle.
And Mike, lots and lots of people have asked, what is your favourite insect, including reception class at St John Bosco. So Mike, what is your favourite insect?
Oh, I've got the orchid mantis that mimics a flower, the Madagascar hissing cockroach that goes psst when you touch it and puts you off. So there's lots of insects I love.
Brilliant. Well, my favourite insect is a ladybird, and we have had another question about a ladybird from Upper B Primary School. Why do ladybirds have spots?
Well, black and red are universal warning colours, and it's warning things like birds, don't eat me because I taste terrible, and they do, they really taste foul. Black and red. Now, the number of spots depends on the species. You get 3 spot, 5 spot, 12 spot, and that tells you what species it belongs to. But normally, a yellow ladybird with black spots or a red ladybird with black spots.
Thank you so much for all of your questions. We've come to the end of the session today, but we have provided lots of follow-up activities for you to complete. As always, please send us or share your photos of these activities that you've completed with us. We love to see your work. Thank you for joining us today. We've had around 10,000 pupils live in the session with us, which has just been brilliant, including St James Church of England Primary School. Thank you for your comments, questions, and Mike, thank you for being a wonderful guest with me.
Pleasure.
And I hope you have a wonderful Science Week.